Lesson 17, References and Pointers. To follow along with this lesson, you will need to create a new console project and add a new file named main.cpp to it, as we did in Lesson 1. If we think of a variable as a location for storing something like an int, a reference gives us an alternative name for that int. The reference contains the memory address of the variable, but from the standpoint of programming, the reference simply contains the variable's value. In this program we declare an int variable, and then we declare a reference to that int. Notice that we use an ampersand to declare a reference. At this point, the int variable and the reference refer to the same int value, so we can make an assignment to the reference or to the int, and it does not matter. Both change the value of the int variable. There are a few things that we should note about references. First, they must be initialized when they are declared. Second, they can never be reassigned to refer to a different variable. Like references, pointers contain the memory address of a variable and offer another means of referring to a variable's value. However, they function a bit differently. This program is functionally equivalent to the last one, but uses a pointer instead of a reference. There are a few differences to notice here. First, we use an asterisk instead of an ampersand to declare a pointer. Second, we use an ampersand in front of the int variable during initialization. The ampersand is called the addressive operator, and it is used here to extract the memory address of the variable. In this case, the assignment operator assigns the pointer the address of the variable. The third thing to notice is that when we want the value that the pointer points to, we put an asterisk in front of it. This is called the dereference operator. The asterisk in this case tells the compiler to retrieve the value at the pointer's memory address. A pointer has all the functionality of a reference, but it is much more powerful. Unlike references, a pointer does not need to be initialized when it is declared. However, if it is not initialized, you should always set it to 0. In this program we show that a pointer can be reassigned. Here we assign it to the address of the variable int, and then to the address of the variable another int. Note that this assignment is different than changing the value that the pointer points to, as we do here. Additionally, we can use a pointer to move through the entries of an array, as we do in this program. We can apply increment and decrement operators, or we can add an integer to the pointer to move it. However, we have to be careful to stay inside of the array. Finally, we remark that we can have pointers of any level of indirection. Here we declare a pointer to a pointer which contains the address of the int. In terms of memory, it looks like this. This concludes the lesson.